In our last video for chapter 6, we're going to talk about acid nomenclature. So we've done ionic nomenclature, we've even done special ionic nomenclature. So it's time to move on to a new type, and we're going to talk about how we name acids. We use them a lot in lab, right? So it's probably good we know how to name them and what those names mean. Well, there are two types of acids. There's a binary, which is hydrogen with a nonmetal, and ternary, which is a hydrogen with one of our polyatomic ions. Now notice they always start with hydrogen. So acids always start with H. What do I mean by that? Let's go to the acid cabinet and find out. Come on! So what do I mean by acids always start with H? Well, let's take a look in our acid cabinet. In our acid cabinet, notice that we have HCl, hydrochloric acid, and here we have H2SO4, which is sulfuric acid, and here we have HC2H3O2. That's acetic acid. But notice that all of my acids in my acid cabinet start with the letter H, because their formulas all have hydrogen in them. Now, we saw that all of the acids start with the letter H. Well, the letter H represents the nonmetal hydrogen. And hydrogen will either be bound to a nonmetal, like chlorine or sulfur or phosphorus, or it'll be bound to a polyatomic ion. And the way we name them is actually different. So let's talk about how we name hydrogen when it's bound to one other element. So when it's bound to just one other element, so not a polyatomic ion, we use this hydro prefix. That's why HCl in that acid cabinet was hydrochloric acid. So we use the hydro prefix, and then we use the stem of the thing it's bound to. So if it's chlorine, then we use chlor, and then we add an ic, an acid. So for example, if it was bound to sulfur, we'd say hydro to represent the hydrogen, sulfur for the sulfur, ic, acid. So this would be hydrosulfuric acid. So remember in ionics, we changed the ending to IDE. For acids, we changed the ending to ic, acid. So H2S would be hydrosulfuric acid. In our acid cabinet and in a lot of labs, we've used hydrochloric acid. So we start with hydro, we name the stem of whatever it's bound to, and then we add ic, an acid. All right, so that's if it's just hydrogen with one other element, and that element will always be a nonmetal. What about if it's bound to a polyatomic ion? Well, this is different. If it's bound to a polyatomic ion, and remember you have to recognize those polyatomic ions, you're not going to use the hydro prefix. So what you're going to do is you're not even going to mention hydrogen. You're going to name the polyatomic ion, and you're going to change the ending. So if it's phosphate or sulfate or chlorate, you change the ending to ic. So phosphic or sulfuric or chloric acid. So ate becomes ic acid, just like we did kind of with the binaries in the last slide. But if it's an ite, like sulfite or chlorite, the ending becomes -ous. So instead of being chlorite, it's chlorous acid. So you have to make sure you can recognize a polyatomic that's an ate, like sulfate, or a polyatomic that's ite, like sulfite, because how we change the ending is different. So ate goes to ic, ite goes to -ous, and always end with acid. So here are some examples. So here is H2SO4. This is sulfuric acid. This is H2SO3, right? This is sulfite, so this is sulfurous acid. So this, right, is sulfate. Because it's 8, we change it to ic. This is sulfite, ite. Ite goes to aus. So remember that the difference between an ate and an ite in polyatomic language is one oxygen, right? We lose an oxygen when we go to the ite. Notice again, there is no hydro prefix, because remember, on our last slide, we had H2S, right? And this, we called this hydrosulfuric acid. Well, how would I know sulfuric acid and hydrosulfuric acid apart if I didn't have the difference with the hydro prefix? Here's another example. So again, don't use hydro. Those, we save those for if this was like H3N. This is nitrate, right? This is the nitrate polyatomic ion. So we change the ending to ic acid. So this becomes nitric acid. The acid lets us know that the H is there. Here is nitrite, right? Ite, because it has one less oxygen than nitrate. So ite becomes aus. So this is nitrous acid. So no hydros. You see a polyatomic ion, don't start with hydro. Name the polyatomic ending, sorry, the polyatomic ion, and change the ending. Ate goes to ic, ite goes to aus, and always end with acid. That tells me that that hydrogen's there. All right, how about writing, how about some practice? Now notice there's no polyatomic ion here, but there's a polyatomic ion here. There's none here, but there are here. So pause the video and see if you can name these correctly. For this one, right, because there is no polyatomic ion, we say hydro. Then we name the nonmetal, which is phosphorus, and change the ending to ic acid. So you should say hydrophosphoric acid. And if you said hydrophosphic acid, I'd be totally cool with that. Now I have a polyatomic ion, right? This is the phosphate polyatomic ion. So no hydro. Name the phosphate, change the ending, that becomes ic. So if you said phosphoric acid, you are correct. Here is the well-known hydrochloric acid. We use it in lab all the time. But what about this one? This is chlorate, right? This is the chlorate polyatomic ion. So again, no hydro. Otherwise, we're going to confuse it with HCl. And we get chloric acid. So 8 becomes ic. No hydro, or we'll get it confused with that one. What's this? Well, remember this is the this is chlorite, right? And ite becomes aus. So if you said that was chlorous acid, you were correct. How'd you do? Well, that's naming, right? So hydro if it's only bound to one other nonmetal, hydrogen with one other thing, one other type of element. And if there's a polyatomic ion, no hydro. But all of them should end in acid. So your endings are either going to be ic, or they're going to be, there it is, aus. But they always end in acid. All right, now let's write formulas. Well, writing formulas is kind of like what we did with ionic nomenclature. Really not much different. The only good thing is we know that everything, all acids, when you see the word acid, think it starts with H. So we're going to write down H every time. All of these start with H. So when you see acid, write down H. And if you go to the periodic table, right, you look at your periodic table, you see hydrogens in that first column, which means it's always +1. Now, what do? Well, this is bromic acid, which means my nonmetal here, the thing that comes next is bromine. The symbol for bromine is Br. And if you find it on your periodic table, you'll see it's in column 7, which means it's -1. Remember that when we write formulas, the oxidation numbers, these charges up here, have to add up to 0. And they do. So hydrobromic acid is HBr. All right, sulfuric acid. Notice there's no hydro, right? If there's no hydro, that means this is a polyatomic ion. And it's the ic, which means this is the sulfate, right? Ic, 8 becomes ic. So sulfate is SO4, And the charge on sulfate is a -2. Remember, this is +1. So in order to get these charges to equal 0, I need 2 of these, right? Or if we use the crisscross method, you can see that this 2 is going to come here. And so sulfuric acid is H2SO4, because this is sulfate, no hydro, which means it's a polyatomic ion. All right, what about this? I got hydro, which means that I'm looking for whatever iode could be. All right, that would be iodine. So we're going to put an I there. Go to the periodic table, take a look. Right, H is always +1. I, it's in column 7, just like bromine was, just like chlorine is, -1. So it's just hi. All right, last one. Acetic acid. What's acetic? That's not even a element on the polyatomic on the periodic table. But there's no hydro, right? Which means that this must be a polyatomic ion. And it's ic, which means that this is acetate. Do you remember what acetate's chemical formula is? I tell you, it's Mr. Fisher's favorite. It's C2H3O2. All right, and remember that's -1. So when I write it here, right, C2H3O2, if this is +1 and that's -1, boom, there it is, acetic acid. You know, that's also vinegar. All right, so do some of the check your learning practice under your notes, and I'll see you in class.